Hi, so let's look at the tensile tester in practice. So this is a tensile tester which can actually measure something inside a chamber. So that's the reason you can't see much now. But if we remove that chamber, you're gonna see more. So we can move back. And now you can see more. You can see that I actually use these long rods as the grips are inside the chamber. But as I just explained before, what you need is you need two grips. You see them here. These are actually pneumatic grips. There is a load cell. It's right here. It's the load cell. And then you can clamp a specimen between the two grips. And here in this setup we have these long rods, and at the top we see the crosshead here. So that's quite the setup. So at the crosshead we can measure the actual location, the distance. And there is a scale here, and it works basically by a screw. So this is a screw-driven machine, and the machine can detect the location of the screw and the current angle of the screw, so it can very precisely measure the location of the crosshead. That's what you can use to calculate specimen deformation. But then again, in here you're going to have the specimen, and you can measure specimen displacement directly at the specimen. In this case here I use a video extensometer, so there's a camera down there, and it's gonna watch the specimen deform, and by analyzing the picture I can compute displacement. But I could also use mechanical extensometers. I'm going to show that later. Yeah, so again, load cell, grips, extensometer that measures displacement inside the grips, and this displacement measurement at the crosshead. And what you can see here is that you have quite something to calculate if you want to compute strain from the crosshead, because, for example, in this case the rod is long, so it can actually do a lot of deformation, a lot of elastic deformation. You have these grips here, and the grips are going to have some deformation too, because in this case these grips are going to move when you add force, because they are self-closing. Gives you some additional displacement though. And that's quite non-linear, so with these grips you're gonna have a hard time computing strain from crosshead measurement. So you actually, in this setup, you should really measure strain using an extensometer. So what else? That's actually the electronics of this screw-driven machine. And in this setup, as I told, you also have a temperature chamber that you can heat or cool. This one works with liquid nitrogen. And I just did some tests at low temperature. That's why they are wet, because they were frozen, and then the moisture from the air freeze on the grips. So that's it.